Hello, everybody. Today, I want to talk about action cable, which is the way WebSockets are implemented in Rails, at least by default. We may use other technologies, but action cable is the way that's hardwired into Rails. Action cable was introduced with Rails 5, I guess. But when you look at any manuals or any how-tos or whatever, make sure to look at the version of for Rails 6, because the Rails 5 instructions are really outdated. So have a look at recent stuff. All right. First, action cable and WebSockets. What's the difference in contrast to normal HTTP stuff? Each HTTP is a request-response-based protocol. So in general, there is no state whatsoever. So you ask a question and you get an answer, and that's it. With WebSockets, every connection is held, is persisted, and you have a stable connection between your client and the server. And this is great for broadcasting information that needs to be handled immediately. So, for example, chat clients are probably the most obvious thing, but also certain statistics may be reasonable, and monitoring stuff and things like that. That means that the normal HTTP tools don't work for WebSockets, but you need different tools. And you don't have just client server and the client asks a question and gets back the answer, but you have on the server side, or you have persistent connections. So you have the server, and you have from every client that is subscribed to one of the channels. There are, you have one WebSocket connection, and so we don't use normal controllers, but we have to use something slightly different. And especially on the client side, you need to use JavaScript because, the client has the persistent connection, and we have to to deal from the page with the data that's being transferred. Today I changed the way I show stuff to you a little bit, because I'm not so 100% familiar with action cable. I didn't use it so far, so I decided to just prepare an example or use an example and look into it and try to understand and try to explain how things are wired together. First of all, in action cable, a Redis server is required. So this is the Redis is a key value store database, which is generally in memory. So it is very, very fast. It's great for using for handling lots of simultaneous connections. And it's other than Postgres, which is really very much multi-threaded. Redis is in general single-threaded. So you have an event loop, and every request is being processed after the other, so you don't get things mixed up. So yeah, I just started Redis, installed it before. So next thing, pardon? Oh yes, sorry. I have this chat room application. This is a Rails 6 application. To get it up, so I stole this from the internet. We will provide the link in the blog. I had to do some updates to get it running with today's tools. But yeah, I'll publish that. All right, so first, let's open it. This is a pretty normal Rails application. So if you look at the gem file, this is a standard gem file. As I said, updated the log, but apart from this, you have Rails, Postgres, which isn't current in the current stack, isn't used so far. The web server Puma, which will do the WebSocket connections too. This is something that changed from Rails 5. On Rails 5, you had a different process to do the WebSocket handling, but in Rails 6, this is baked into Puma. Yeah, and that's mainly it. So you don't need any special things. This is all baked into Rails. In the application, let's do this one by one. There is this channels folder, and channels are to some extent the equivalent of the controllers in the HTTP world. So a channel is responsible for dealing with all the requests and all the subscriptions. And by default, there is this application cable module. So this is the way it is done normally. And inside you have a channel which inherits from action cable channel base. Again, this is so application cable channel is kind of your default WebSockets handler. And you have an application cable connection, which is which represents the connection. And the let's just start the application so you can see what it does. Okay, so first you might see that here the number of threads that is spawned is at least 5. Normally, with everything we did so far, we used in development, we used Puma pretty much single-threaded. But for the WebSocket stuff, you do need multiple threads. Okay. So let's see, we started it on localhost 3000. All right. And we have a chat room. So I just add a name. Peter. I click submit. Peter joined the room. And if I probably decrease the size a little bit. And if I type something here, click on send, this will be here, but there's no one there to see it apart from myself. So I just start another browser. This would work with a different tab or a different window of the same browser too. And everything is very immediately. So you see, when I type something here, this really shows up in the other browser immediately. Of course, this could be implemented using polling. So you could just ask, is there anything to know for me? And do this in a request response based way. But in this case, there is a persistent connection, and so all the other clients are informed immediately when there's new data available. So let's have a look what's going on with the server. Okay, so the home controller index. This is not too surprising. And now we see there is a WebSocket connection. And we can see what's actually happening. So there was this announcement that Peter joined, and this was then broadcasted to the chat room channel. So with Action Cable, you have the concept of different channels to which you may subscribe. And so in this case, we just have this default, or there is the one channel, which is the chat room channel. And then we have this the announcement that the event is of type join, and the name is Peter. And a little bit down after the other one joined, we see this Paul of type join, and this was then transmitted twice, once to the Peter connection and once to the Paul connection. And then Paul said hi, and this again was transferred to every connected client, which is twice. So, and if we open another tab for localhost and add another name, you see everything is transmitted 3 times. So as you saw, the Puma is running with 5 threads, so we are slowly running out of connections. But it is neat to see that you don't necessarily need another server like, say, Node or whatever, which are pretty well prepared for these kind of simultaneous connections. But you can just do this with the standard Puma that is included in Rails. Of course, this means a certain overhead. So these connections are persistent. So you have this is implemented with threads on the Ruby side. So the Puma is actually using multiple threads and to communicate to the client. So let's have a look at the code again. We have this chat room channel. And when we are subscribed, we tell that we want to stream from the chat room channel. After unsubscribe, we could do certain cleanup stuff like destroying sessions or deleting users or whatever. Then we have this speak, which is invoked whenever a new message shows up, and an announcement that is telling that someone entered the channel. So we don't have any proper controllers. There's only this stupid home controller that does actually nothing. So there are no models involved and nothing. No interesting helpers, but and the view is very straightforward too. So the view is really just this one file, which provides the chat window. But what's interesting is JavaScript channel, chat room channel. So in the application.js, let's start here. We first required Rails.js as always, turbo links as always, active storage. We don't use that, but still. And we require channels and jQuery. And channels requires the index.js in the channels folder. So this is where we go. Channels itself requires the chat room channel. So yeah, every file that is starts with that ends with _channel. So in this case, we have just one. So we have this chat room channel, which imports a consumer, and then we create a consumer and a subscription for a chat room channel. What we do is we type that we inform about the connection on the console. Oh yeah, the console is everything's so small. This is really annoying. Yeah. So this is the console, and we show the modal. The invocation, the actual invocation is done here. So when we set name. This is the moment when we submit the login screen. Then we just grab the name, remember it, and then go to the chat room channel and announce that we joined with the name and hide the modal again. So let's just close this, restart it. So this is the modal. And when we type something and click on the submit button, this is the code that's being executed. So we tell that we announce on the channel that we joined in the moment. Bam. And when we type something here, this is then the send message thing. On send message, or on submitting this send message form, which is there, we go to the chat room channel and we speak our message. So we just take the message and send it to the channel. So we are then sending something to the channel. And the obviously we can't change anything on the other for the other chat rooms. So this needs to be handled differently. So what's done here? When we receive data, this is then called magically whenever there is data being transferred over the WebSocket connection. We first check whether the data has a message, and if so, we check. So we use this session storage to remember our own name. So we check whether this was sent by us or by someone else, and we append the message to the messages div. So this is this one. It's really size is really somewhat annoying. Yeah, this is the messages div, and we just add the all the messages that we receive. And this received is invoked automatically whenever some data is being transferred over the WebSocket connection. So there's not a lot we have to do ourselves. So we really just have to consume the data, and of course the design of the transferred data is pretty much our choice. So there's no need to transport the JSON in one way or another. So the actual code of this received block is depends a lot on what you're actually doing, and this could of course be factored into different handlers and stuff like that. But the principle is always the same. And in this case, so we have messages and we have this join information things. So if we don't have a message and we have a chat room name attribute set, then we joined or left, depending on whether it's the type is join, and we add the announcement. So this is pretty much all that is necessary on the to implement the WebSocket connections here, and to have this synchronous communication between different clients and of course the server and the clients. But we have everything at our hands. So when we go to the chat room channel, for example, and we just let's just go to this and add some more Rails-ish stuff to this to the chat room channel. So we could, for example, add a model. We call it message. application record. This is message RB. Whoops. And we use a different. Use the correct Ruby version. And we generate a migration, create messages, and let's say username string and message string, doesn't really matter. All right, so now we should have our message model at our hands. All right, so we have a string username and a string message. So let's just migrate this. Okay. So if we now open the console, we can say message.all. There are none, but yeah, everything's there. Okay, and what we could now do is we could go to the chat, go back to the channel, and whenever someone speaks, you can just message dot create user and text. This is the stuff we got from the got over the wire. Our names right? Username and message. Anyway, username and message. All right. So, and we do message create bang. So probably just to remind you, message.create will return true on success and false on failure, whereas create bang will either create or raise an error. So we just know whether something went wrong. Okay, so if I now type something, whoops, and send, then okay. This is something I think at least I have to restart the connection. We're just reconnecting. So again, some name, and now I send a message. All right, and now the message was persisted. So we are using the exact same models, and we can use exactly the same strategies as we use in other Rails projects. And so we could, for example, add something like data message and message, and for example, add in parentheses message.id, which is not actually helpful, but yeah, you can just to see that we are again. I don't know whether I have to whether reloading is sufficient or not sure about that. Yeah, reloading is sufficient. So now this is message with the ID 3. More stuff, and of course, okay. yeah, all the stuff will be persisted, and we can, of course, use this to probably create an archive of the chat. Otherwise, there is the information that you see in the chat is not really persisted. So the Redis stuff is really just used to grab the data from the channel and post it back to all the other guys. But it's not a tool for persistence. If you want to persist stuff, you'd have to stick to the good old active record stuff. And of course, this can be used to probably, for example, inform you whenever something happens in your standard Rails application. So you could just use all the standard HTML stuff. This could be a completely generated form, of course, a generated HTML thing. And even only if someone logs in, probably you could just blink or rotate or whatever. And of course, we can create a messages controller, stuff like that. Channel controller, messages controller, RB. Class messages controller inherits of application application controller. Okay, here scanning. The normal view. Oops. New folder, messages, and add our index. HTML slim. And I'll do it completely stupid. Messages all each do message, and then message username colon message. Well, the naming isn't too consistent. And we have to add it to the routes. Resource messages only index. All right. So we could now localhost messages. Oops, there should not be a 1. No route matches this. Why not? Resources messages. Missing a template. So there was not. Oh yeah, we didn't include Slim. Thank you. I'm so used to using Slim that I just forget this isn't default. Okay, so on this page, you can then see all messages, and you could of course also create a message here and send it to all subscribers. We should probably just do that, just to see that the two worlds they interact properly. So there's really no nothing between them. So log in again here, and let's add index, and we need new, and we need create. So we go to the messages controller, add our standard new action, message new, and add our standard. So in this case, again, using some meta-programmed automatically generated controls would be really neat. Create messages message.new of message params if message.save, then redirect to messages path, else render new. Okay, this is just default stuff. And there's another thing to add for simplicity. We use simple form. Simple form isn't required, but it just reduces the amount of stuff I have to type. So I prefer using it. Sadly, we have to restart the server for that. Okay, so let's go to the index page. Href new message path. And now everything will break because we don't have a template for new so far. So new file, new HTML slim, simple form. For message, do f.input username message and submit. So I do know this is incredibly ugly, but this isn't about web design actually. So username, blah, message, create message. We didn't define the message params so far. Def message params. And as always, params require message and permit username and message. Okay, but we need to relog in here. Okay, nothing happened. This is because just relog in properly. Yeah, because we didn't do anything with the channel, so we just go and see what happens at the JavaScript where we channels. We go to the chat room channel, and what we need to do is we want to use this speak thing. So we go to the messages controller again and action cables server broadcast. Of course, this needs to be abstracted into some generic place. So this should not be distributed all over the application, but just for principle, chat room channel message, and this is then message dot message. Message ID is fine and sent by message dot username. So this is then triggered from the from a normal Rails controller. So let's see whether it works. New username. No, it didn't, because I forgot the @ because we didn't. So we are using the instance variable message here. So reloading is something that's not completely clean, not as clean as the zero turnaround stuff that you have with the standard HTTP stuff. But still, it worked. So we triggered this somewhere, and we could even trigger these broadcasts from background workers, whatever. So anything, any Rails code that you're using, or Ruby code even, can use this to broadcast informations. So yeah, for example, for monitoring purposes, or for creating some fancy dashboards and stuff like that. This can be used, and this can even, although I really don't promote that, but we could even go and add this to the model, which is definitely the wrong place to do it, but just for shits and giggles. After create, do. So we don't need this message doc, because this is where we are. So now we have this callback in the model, which is, as I said, this is really nasty. You shouldn't do that. Even if you decide that you want this to do this with a callback from the model, you should, at least this code should never be here. You should definitely produce another object or another class to handle this. And we can even, we can just do that in a moment. And we don't have any code in the controller that is responsible for this stuff anymore. So let's see, probably reload here, because it will break anyway. Okay. So create a new one. A. So this was now triggered from the author create callback of the model. And what I'd suggest very much is to create something, for example, so all the code that is that lives in a folder directly below app is being loaded automatically. So we are just free to decide that we want to use a broadcasters model. Broadcasters. This is broadcasters? Broadcasters? Broad. This is right, I think. Yes. And we now create a class message broadcaster. Yes. .rb. And this can even, just for consistency, inherit from application broadcaster. Which is a typical pattern in Rails. So we add another file, class application broadcaster. So we can now, add something like, for example, let's say send data, just whatever it is. And we can then, say application, action cable, server, broadcast. This is, pretty much static code. We need this. We can just say every subclass of application broadcaster needs to override channel name. So we can say server.broadcast channel name. And the actual message is then just data. Oh, we don't even need that star thing here. We can just use data. All right. Okay, and then the message broadcaster has to do is to override the channel name to be chat room channel. And then we could go back to the model again, say we want the message broadcaster to send this, and this is at least somewhat neat. It's not as ugly as before. Yeah, I'm afraid we have to restart this one again, reload this one again. And I think I have to restart the server because I added a new directory, and this generally isn't included in the reloading magic. Okay, and if we say new here, apart from typos on my side, this is not a symbol nor a string. No, this is not a symbol nor a string. I'm pretty sure of that one. Let's just see what's message. Oh, this is, I'm so stupid. Send is one of the very, very few methods that you should never ever override, because this is the this is the way methods are invoked. So yeah, let's call it broadcast. This was very stupid. Application broadcaster. Oops. No, still not broadcast. All right. Overriding send is really one of the worst ideas you can have in Ruby. I'm very proud I had it. Yeah. Oh yeah, of course. What I did here is I tried to call a static method on an instant method on a static class. So yeah, probably let's do that. Let's go to the application broadcaster and say we implement self.broadcast of data, and this then calls instance.broadcast of data. So this is to some extent a single, not really, but somewhat like that. And we then say initialize, which is the constructor in a way. Oh no, let's make things even better. Let's say we define a function self.channelName of name. And then say instance equals new of name. So we are producing an instance of our own class with a parameter name. So initialize name. We remember channel name equals to name. Okay, and then broadcast of data of this one will be just name. And instance broadcast. Ah, yeah, and we have to add an add here. So what we can now do is we can just say channel name, chatroom channel. This will invoke the channel name method of the application broadcast or of ourselves and create an instance. Oh, here, and we'll create an instance of ourselves with the name as the channel name, and we can then call broadcast on the class, which will then use the instance that knows about the name to broadcast the data to the world. So this is the message broadcaster. So things should work now. Oh yes, of course. We remember the name in the add channel name instance variable, and we have to use this here too. Otherwise, that can't work. Merp. All right. So I guess this didn't work out here because we have to relog in. Submit. And name message. And the data will be broadcasted. This is pretty much a standard pattern in Rails. So whenever you identify a special domain object, just create a folder below app, add an application, whatever domain you are working with, put the basic implementation there, and then create the required subclasses. And yeah, so in this case, we were able to use this message broadcast in a pretty neat way, I think. And of course, we can now go back to the channels stuff and replace this with the message broadcaster.broadcast too. Just so now everything is at one place, and when you're running into trouble or decide to do or not do things, you can just change them there. And we can even decide that the message broadcaster itself is responsible for the persistence. So in this case, because we are using the after save hook, it doesn't make any sense because it will go into infinite loop. But we could say message dot create of oh yeah, we can Yeah, let's do it like that. The broadcast message for, method for the message broadcaster needs two parameters, name parameters, message and sent by. And this creates a message object with a username sent by and message.message colon message. So this creates the actual model, and then it just goes up to super with well, I don't know whether this works because we changed the signature. We'll see. This might work, it might not. I'm not completely sure. Of course, we have to remove this from the message model, and the create will then turn into just broadcasting this shit. So what we do is we say message broadcaster broadcast, and the message is message params of message, and sent by is message params of username. And this should automatically create the correspondent object. So we're moving the responsibility for the persistence into this broadcasting model, which can then save stuff. And this could, of course, even be moved into a delayed job or background worker of any kind or whatever. So let's see whether this works. We have to remove this persistent stuff in the speak thing. And we will run into trouble because this message broadcaster.broadcast doesn't contain message and sent by, but chat room name and type. So in this case, we will run into trouble in the moment that we reload here. This should directly produce an error. We have to restart it because we changed the channel state thing. Now we should run into the error. So why didn't we? Message broadcaster.broadcast, message broadcaster.broadcast. We don't have the correct signature here anymore. We are calling this announce thing. Oh no, just debugger. So data, we don't have. So now we want to call the all right. So we are calling the broadcast method of the message broadcaster class. We didn't change the signature of that one. This is why this didn't cause an error. So where is it? So in the application broadcast, so we just called this broadcast here. And we called it then the instance with the data. well, probably this is not neat. So we should have changed. We shouldn't do it like that. We should really just stick to data here, and say send by equals to data of sent by, and oops, message equals to data of message, and just persist this stuff if message present. So like this, we won't run into the problems of having different signatures for the methods. Data. All right, try again. Oops. I have to remove the debugger. Okay. So we joined the chat room and we decided to say something. And this did not work out. Name error, undefined local variable, message for chatroom channel. Chatroom channel. Of course, this ID magic doesn't work anymore. This is totally consistent. All right, we log in, send a message. Okay, at least the sending was successful. Yeah. Okay. So in this case, we are accessing this data thing with symbols, but it might even depending on whether it comes from from a form or it comes from the web service. This might be symbols or strings. So in this case, we can just say data sent by as a string. We could also do things like there is a class hash with indifferent access that uses strings and symbols the same way. So when there is an entry for a symbol and you access by a string, the same thing will be returned. So again, restarting. And let's see whether this was. So the message controller is broken. Where is it broken?
There's an edge.
Yeah, there's one. Yeah, thank you. No, this was not persisted. So we do message broadcaster.broadcast. Then we go to this is calling self broadcast, which is then going to data. I think I messed up with the names because I didn't use the same symbols or the same attribute names for the model and for the for the broadcasting attributes. So this is why we are everything's a little bit messed up now. Let's just write it down here. We can see. So the parameters. Started post-processing, broadcasting, message this and sent by that. This is correct. Transmitting, this is all fine. But we didn't find... What we have to do, of course, is we have to redirect to messages path. Yeah, okay, so at least this works. So why isn't this persisted? We have message and sent by. This goes to the broadcast of the class, and this goes to the broadcast of the instance. And in the message broadcaster, this might be the reason I just missed. There was just a stupid typo. All right, so let's try it again. A and N. A and N. And yeah. Here. Submit. Again, this one. UTU, that worked. So let's see what happens when this guy types something. Actual message. So the actual message was sent and it was also persisted. So yeah, we can use this action cable stuff completely, intertwined into the normal Rails application. And whenever there is a need to have something that needs, whenever there's something that needs really immediate action, we should use that. On the other hand, it is quite reasonable not to overuse things like that, because there is some overhead for the WebSocket communication, and if you have, for example, some statistics view which is sufficiently detailed, if it's updated every 10 seconds or 30 seconds or something like that, then just normal Ajax reloading stuff is really just fine. You don't need to use action cable or WebSockets for everything. You should really stick to that when you want, or when you have when you really need immediate feedback about some things that are going on. And even we have in our applications, we have certain processes that take quite a long time. Certain things even take up hours and are done in background workers. And it's just not reasonable to have a WebSocket connection to find whether things are done or not, because it's just sufficient to ask every, say, 5 seconds, are you done? And this connection is very cheap, and it for the server need not hold up so many connections. And if, for example, if you have a load balancer, setting things up is a little bit twisted, and the load balancer would need to have all these connections open too. So yeah, it's really reasonable to use it only where necessary. But for example, for a chat, this is probably the best way to go. And for this reason, we ask you to implement a chat. Well, almost everything is here already for the last exercise. And now I think Christoph will tell you something about how to actually produce your last exercise. Is this part of the video, or shall we just stop it?
We made a second video.
Okay, so yeah, then I stop here, and then we'll restart the video about how the last exercise is to be made.